Good day. We are the group of conveyors, and our group members are Eliza Valleza, Kate Renee Carriazo, William Jefferson Onya, and Jade Andrea Vasquez. For the first problem, we have profit maximization using the graphical method. It says here that a manufacturer needs help in choosing how many units of STD or use. The first step in profit maximization is to set up the objective function and constraints in mathematical format. To do this, we would need to identify our decision variable, problem objective, and constraints. For the decision variable, we will have STD as our x and DEL as our y. The problem objective is to maximize profit. To put it in mathematical terms, we maximize z equals 125x plus 110y. Here in tabular format, you can see the 5 constraints. Next slide. For the second step, we would need to plot each of the constraints in a graphical format. Here are the graphs from the coordinates and the constraints. So the first graph we have for S and P, the second is for motor, and the third is for STD control. Next one is for our DEL control, and the last one is our A and P graph. So the final graph will look like this, given that all the constraints are plotted in it. So the third step in profit maximization is to identify the feasible solution space. In profit maximization, we get the feasible area from the smallest lower left-hand corner in the graph, which is in this case the highlighted area here. There are 6 corner points identified. Each of these corner points' coordinates will then be substituted to the problem objective in order to get the optimal solution. In this case, the most optimal solution to conclude, the manufacturer must produce 1,000 units of STD dryer type and 400 units of DEL dryer type to maximize the profit to $169,000.
For the cost minimization problem, the question is how many cubic yards of each food should a farmer blend to meet the minimum chemical requirements at a minimal cost? And what is the cost? So we made a table of the given data from the problem. Our objective function is to minimize C is equal to 30x plus 25y. Our decision variable is let x be the quantity of plant food mix A and let y be the quantity of plant food mix B. We then identified our constraints, which are for the phosphoric acid, nitrogen, and potash, including the non-negativity xy, and substitute each of these to be able to get values of point A and B coordinates. We have shown here the point coordinates of each chemical requirement, as well as the graphs that we have after plotting all the coordinates. Then, after plotting all the coordinates, we have identified the feasible space and started to look for the optimal solution, which was done by using the objective function formula to substitute with the value of our corner points, which is from the constraint potash. So we found that there should be 46 cubic yards of each food to meet the minimum chemical requirement at a minimal cost amounting to 1,380.
Okay. In this problem, BOM Manufacturing has 3 plants, P1, P2, and P3, that all have retail shops B1, B2, B3, and B4. This table shows us the shipping fee for each plant and their respective retail shops. Next slide, please. BOM Manufacturing wanted to build a new plant from these 2 locations with this respective shipping fee or cost. Since the total demand is 3,100, it implies that the capacity should have an equal value of 3,100. The difference of the demand and capacity will be 500, which will be the new plant capacity. Next slide, please. This is the table where the location 1 shipping cost is added to the overall table with shipping costs of 6, 6, 4, and 7 from B1 to B4 respectively. Next slide, please. Okay. On the other hand, this is the table where the location 2 shipping cost is added to the overall table with shipping costs of 4, 5, 8, and 4 from B1 to B4 respectively. Next slide, please. By comparing the total cost of location 1 and location 2, BOM Manufacturing must choose location 1 with 6647 of transportation costs for B1, B2, B3, and B4 respectively for building a new plant because it only costs $12,100.
For portfolio management, the problem asks us to determine the best allocation of the availability capital of $40 million, which will be the highest possible investment gain. Next slide, please. So we have here the table that shows the 5 types of investments of which we can allocate the capital of $40 million. The types of investment will serve as our decision variables, labeling them as X1, X2, X3, X4, and X5 respectively. Along with this is the data about the annual growth rate and probability of losses. Next slide, please. It is important to identify our objective function formula, which we can solve using the formula of expected growth from good investment minus expected losses from bad investments. Next slide, please. The identification of objective function, we analyze the mentioned constraints, which include the following. Next slide, please. The solutions from the identified constraints are displayed in this slide. 1 to 5 constraints. Next slide, please. Since we already identified the necessary information, we were able to determine the possible allocation of $40 million investment by the use of Excel solver. The optional solution is invest in balance and bounds with an amount of 16 million and $24 million respectively. The initial investment of $40 million will gain us a profit of $785,600. Next slide, please. And that's all for our presentation. Thank you and God bless.